Uh, okay, both of you should have calculators with you, so you have to check the calculations that we will be doing over here. Today we'll be solving questions of errors and uncertainties. It is a very common question. Mostly first question your paper 2 is from this topic, and the equation that examiner will give you will be a new equation that you are not familiar with. In this case, he is giving you an equation for speed of a transverse wave um, in a uniform string. T is the tension in the string. T is tension, so it is a force in newtons. L is the length and m is its mass. An experiment is performed to determine the speed v of the wave. The measurements are taken or are shown in the table. If tension is 1.8, length is 126 centimeters, mass is 5.1 gram, then and uncertainties. This is the case exactly what I was talking about in the last class, that if examiner gives you uncertainty in percentage, you have to follow the percentage rule. In this case, you cannot follow that uncertainty rule where absolute uncertainty is given. So you should be good with both of the methods that we discussed yesterday. State an appropriate instrument to measure length. It can be 2-meter rule, meter rule. Both are okay. Or measuring tape, using measuring tape to measure wire is not a very good idea. So I will go with meter rule, 2-meter rule or meter rule. Use the data in figure 1.1 to calculate speed V. So there is a 2-mark question, and all you have to do is just put the values in the formula over here. So how easy it is. But you know the trick, units. Newton is good, but look at this unit. It is centimeters. You must convert it into meters. Then gram. It should also be converted to kilogram, converted to meter. So this is all that you have to do in this case. So calculate speed V. V equals to tension is 1.8, length is 1.26, and 5.1 into 10 to the power minus 3 kilogram, square root. So very quickly, if you put everything in calculator and tell me the answer for this part.
21.1.
21.1. Can you give me one or two extra significant figures? Like what is
Sir, I
what?
got 21.088.
0.88. Yes, you're right. It is 21.1 meter per second. But I will keep this answer in case. Now, look. Use your answer in B1 and data in figure 1.1 to determine the value of V with its absolute uncertainty. He's not asking for percentage uncertainty. He's asking for absolute uncertainty. Now, this is where you have to be very careful. I hope you remember I told you that the percentage error in the product equals to sum of percentage errors of the factors. So all you have to do is just add the error of t plus error of L plus error of M. But the problem is there is a square root on the top. That means actually the formula is V equals to TL over M whole power 1 by 2. And what do we do with the power? Power is supposed to get multiplied with the percentage uncertainty. So it will be, now for the percentage uncertainty of V will be 5 plus 1 plus 2. You can either multiply half with all of them, or you can take common and multiply the total thing with half. And it will become 4%. So there is a 4% error in the value that you have calculated previous in the previous part. So this would be step number 1. Step number 2 is calculate 4% of 21.088. Or you can use the answer that you already have in your calculator and find 4% of that.
0.844.
0.844. So that means that my rough answer is my raw answer is 21.088 plus minus 0.844. And this is my raw answer. What should be my final answer? So when we are finding final answer, the error should be reduced to one significant figure. So it will be 0.8 plus minus 21.1. So 21.1 plus minus 0.8. Okay.
Yes, sir.
Any confusion?
No.
So if you see same kind of question in future, I hope you be able to solve it. Now, in this case, you can interrupt anytime you want to, okay? So if you think you want to ask something or you want to give some input, you want to solve the question, I'm open for that. The mass, like this is make an estimate. So it is a direct estimate. You have to estimate mass of a wooden meter
0.5.
rule. 0.5 is an acceptable, but have you ever
So
hold
0.
a meter rule? Have you ever hold a wooden meter rule
Yes.
in your hand? And I hope you have also hold a half liter 500 ml water bottle in your hand as well.
Yes, sir.
So this is that 500 ml water bottle that you play flip with. Okay, this is 500 ml, also known as half liter bottle. Now, and this is the meter rod that you have in your lab. I'm talking about that long ruler, long wooden ruler. Do you think the mass of the wooden ruler and mass of this thing is same? Because this is half kg, exact half kg. If you want to have a precedent in your head that how big is a half kg, how heavy is half kg, how do we feel when we lift half kg, you can recall your muscle memory and ask for look for the memory of holding 500 ml water bottle, because that is exactly half kg. So do you think the ruler is same as that bottle, lighter than the bottle, or heavier than the bottle?
So lighter than the bottle.
Okay, that can be your opinion. Anybody else with any other opinion?
Lighter than the.
Okay, how lighter? So do you think that if I had two rulers, will that be equal?
I don't think so.
No,
Three rulers?
sir.
Yes, sir, close
No,
to
sir.
it.
So you want to say 0.15 kg or 0.2 kg? What should be the answer? Like, I cannot give 3 answers. Remember, if I give 2 answers or a range of answer, it will be incorrect. So give me one answer. Like, it can be different for person to person. Like, person A can have 0.2, person B can have 0.15, person C can have 0.25, but one person cannot have 2 answers. And one more thing, only answers that are impossible to have will be out of question over here. So if somebody says it is 1 kg or 2 kg, or somebody says 0.01 kg, then it will be wrong. Wrong, wrong, wrong. But if somebody says 0.5 kg, I think that is very super stretched, but examiner should accept it. But the best answer can be 0.2 kg. Okay, so 0.15 is okay. Even 0.1 is acceptable. 0.1 will not be a kind of question that examiner will throw into dustbin. He will consider that. But 0.1, 0.2, 0.3, they are the best answers, but up to 0.5 examiner can easily accept. Now, another question. What is the volume of a cricket ball or a tennis ball? Now, if you have a ruler in your hand right now, estimate diameter of a tennis ball. If you have ever played cricket, you would know how big is a tennis ball. And if you have a scale nearby, let me know what you think is the diameter of the tennis ball. Each one can tell his or her own answer.
I think it's like 5 to 6.
Now, do you have a scale in front of you right now?
Yeah.
So on the scale, give me just one number, 6 or 7 or 5 or whatever you think.
6.
Okay, 6 centimeter as the diameter. Okay, anybody else?
Sir, 6.5 centimeter.
No, you have to be in one significant figure. Either you can say 7 or you can say 6.
So 6 centimeter.
6 centimeter. Anybody else with any different diameter? Nope. Okay, let's consider it is 6 centimeter. Now, if diameter is 6 centimeter, that means radius equals to 3 centimeter and volume equals to 4 by 3 pi r cube. So let's put this thing into the formula and see what we get. 4 by 3 multiplied by 3.142 multiplied by 27. So 113. So I will go for 120 centimeter cube. Okay, I have to give answer in like near about. So 110 centimeter cube is okay. 100 centimeter cube is acceptable. Like, examiner will accept any answer between 100 and 200 centimeter cube. Okay.
Yes, sir.
So now again, errors and uncertainties. Look at the size of the question. Look at the marks. This kind of question need real respect. Okay. So here we come. Mr. Honorable question. The diameter, length, and mass are measured to determine density of a metal. The variants of values are diameter is this, length is this is this. Calculate the density of the metal with absolute uncertainty. Give your answer to an approximate number of significant figures. So everything that we did here for like these two parts over here, 2 marks and 3 marks, he is giving us an opportunity to do all that in just one part. So we have to first find, now like in this case, what we have to find another. He's giving us and need density. So we have to embed this formula of volume into the density formula. Because listen, one thing that we cannot do, solve this question as two separate questions. That will make our job like 10 times longer. So we cannot split it in two questions. We cannot first find volume and then find density and its uncertainty, because if we do that, first we have to find volume and its uncertainty, and then we have to find density and its uncertainty. That will be a very long job. So what we can do is we can embed the formula of volume, formula of density, and this is how we do that. We know density equals to mass over volume, or we can write it like density. For people who are not very comfortable in fractions, they can do mass divided by volume. So it is mass divided by, let's input the formula of volume over here. Pi d square L over 4. So if you remember solving division in fractions, what we used to do was we write the first fraction as it is, replace the division sign with multiplication sign, and reverse the fraction coming ahead. So now we have a direct formula for density. So we don't need to do intermediate calculations. We now have OM over pi d square L. Let's go. Let's use this formula to find density. First step, calculate density. Okay. Second step, calculate uncertainty. So density, let's go for density. Density, this is step number 1, equals to mass, which is 0.225 into 10 to the power minus 3 multiplied by 4. Remember, it is 4m divided by pi. Calculator can put the value of pi itself. D square, what is D? 0.38. And remember, there is a milli with it. That means 10 to the power minus 3 square into L, which is 25 centimeters. Remember, it is in centimeters, so we do 10 to the power minus 2. So here we go. Put everything in your calculator in one go. Just replicate this whole thing in the screen of your calculator and press equal.
Sir, 7940. Mm, 7940.
So I got 7,000. That is the 35.7.
7,900.
35.7.
Okay. Is it okay? Somebody else was telling me 7940, I guess. Yes, like you're right. You're right. You're right. You were rounding it off in 4 figures. Perfect. Perfect. So this is my answer for kilogram per meter cube for the density. Now, what is the second step? Calculate the uncertainties. Now, this is where you, like in this case, examiner is open. You can use the fractional uncertainty technique, or you can use percentage uncertainty technique. I will recommend that all of you practice both methods over here. Okay. I am going for fractional uncertainty, and you are open to do it with percentage uncertainty. In that case, you have to find all their percentage uncertainties. For the first one, it will be 0.01 divided by 0.38 into 100. Okay, this is how you find all the percentage uncertainties, and then you just add them, but just keeping in mind that there was a square on D. You just add all the percentage uncertainties, and then uh, you calculate that much percent of the measured quantity or calculated quantity. But this case, I'm going for fractional uncertainty. Okay, so I don't know the uncertainty of density, so I will consider it X. So fractional uncertainty of density will be uncertainty of X, uncertainty of the density divided by density equals to fractional uncertainty of M, which is 0.000, sorry, too many zeros, 1 divided by 0.225. This is fractional uncertainty of M plus D, which is 0.01 divided by 0.38. And remember, I have to multiply it with 2 because there was a square, plus L, which is 0.1 divided by 25. Okay. So for the value of X, what you have to do is you just have to replicate this thing in your calculator, press equal sign, whatever you get, multiply that with 7935.7, and let me know what error do you get, what uncertainty do you get. If you don't understand, ask me right now. Otherwise, you can do it and tell me the answer.
So I will multiply this with the previous answer.
Yes, you have to like first calculate the I hope you can see the screen. You have
Yes,
to
yes.
replicate this whole thing. You have to replicate this whole thing in your calculator. Find this answer. Whatever you get, you have to multiply it with 7935.7.
484.68.
4.
84.68.
68. So this is the uncertainty. This is the magnitude of the doubt we have in this calculation. Okay. So now my raw answer. Seven nine three 5.7 plus minus 484.68. How will I reduce it to the final answer? So number one, I have to reduce this thing to one significant figure, which will be 484 in one significant figure. What it should be? Most of the students say 484.7. That is a
500.
very common
35.
answer. But we have to reduce it to one significant figure, not one decimal place.
500.
Anyone?
500.
Are you people in class?
Sir, 500.
Sir, is it 500?
Oh, thank you for reminding me that. Now, look, 484, is it close to, like, number one, it is in hundreds. Is it close to 400 or 500?
500.
500.
So that means in one significant figures, it will be 500. Now, the only significant figure we have, its decimal value, its decimal position is hundreds. So that means it allows us to round off this quantity to hundreds. So which number is at the hundreds position? Is it 7, 9, 3, 5, or the second 7?
Sir,
Three.
3.
No. If, for example, if you have to read it, will you read it 7,935 or 79,357? Which number?
79,357.
Are you sure? Do you see this decimal sign over here? Is it visible? Mind the decimal sign. Which position is at the hundreds? Please. Like, the first value is a unit. The second value is tens. The third value is hundreds. This is what we study in, like, second grade, I guess. So which position is at hundreds? 9. So that means that we have to round it off at 9. So what we will have. So what is the number next to 9? 3. So that means when we will be ignoring any value after 9, that will just go away without changing anything. So it will be 7900. 7900 plus minus 500. So that will be my final answer. Now we have another question. Anybody who has tried this question before?
I did try to
Because
find it.
I gave you three, like,
Yes,
all
sir.
these questions to practice. And I was expecting that you have already done them. So let's do another question. An analog voltmeter is used to take measurement of a constant potential difference across a resistor. For these measurements, describe one example of systematic error. 0 error. The voltmeter does not show zero when there is no PD across it. So that will be a systematic error, zero error. A random error. The needle, remember, it is an analog. I hope like sometimes students miss this word, analog. So it is not the one that shows numbers. It is the one that is that has a needle like speedometer in your car does. Okay. For example, if you have a digital car meter, then my example will not make sense to you. It is a meter with a needle, and I know for most of you it might be a new thing, but analog voltmeter has a needle, and sometimes that needle is not very friendly. It starts dancing or it starts vibrating across the value. Okay, the needle is fluctuating.
Yes, sir.
Okay, so
Yes.
we cannot take the reading, so we have to make a guess. Okay, it is vibrating around 4.3 and 4.4, so let's make it 4.3. So that would be a random error, because you can sometimes consider it 4.3, sometimes you can consider it 4.4, sometimes you are making a positive error, sometimes you are making a negative error, sometimes you're making a bigger error, sometimes you are making a smaller error. So this kind of error that you cannot tell how much that error was is called random error. The potential difference across the resistor is measured as 5.0 volt plus minus 0.1 volt. The resistor is labeled as having a resistance of 125 ohm plus minus 3%. Calculate the power dissipated by the resistor. What is the formula for power in terms of voltage and resistance? The formula for power is power equals to voltage square
Multiply
over
by
R. V square over
R.
R. So it will be 5 square divided by 125. So 25 divided by 125, 5155, 0.20, 0.20 watt. And please make sure that calculations are correct. Now calculate the percentage uncertainty of the calculated power. So we need now the percentage uncertainty, and he has given us the absolute. Oh, he has given 1% uncertainty and one non-percentage uncertainty. So he is forcing us to make a mistake. Okay. Now we don't need to do anything with this because this is already a percentage. Let's convert this one into a percentage. In percentage, it will be 0.1 divided by 5.0 into 100. So
2%.
2%, 2%. So voltage has a 2% error. So what should be the percentage error of power? How much doubt we have, percentage doubt we have for the value of power.
That's
It will
7.
be, anybody?
Sir, 2 plus 2 plus 3 is equal to 7.
So because there is a square on the voltage, so we have to multiply the power with the percentage uncertainty, and then we have to add the resistance uncertainty. So we have 7%. So just for doing this, we got 2 marks. Let's see, last 2 marks. Determine the value of the power with the absolute uncertainty to an appropriate number of significant figures. Now, what he's asking us to do, we know the power is 0.20 plus minus 7%, but this is a percentage uncertainty. We need absolute uncertainty. Can anybody find 7% of 0.2? It will be 7 over 100.
0.014.
0.014 Now, it is 0.20 plus minus 0.014. Like we don't need to do that because we can just simply ignore 4 because it is less than 5. And absolute uncertainty has to be in one significant figure, which it is now. And because it is in second decimal place, we have to round off the quantity to second decimal place, which it already is. So all we have to do is just very easily write it here. This is how easy it is to get these 8 marks. If you see, this is easy. Okay. Complete the 3 other questions, and tomorrow we will first complete them and then we will start the topic of kinematics. Any questions?
Yes, sir. No.
No, sir.
Thank you very much. See you people tomorrow. Take care. Allah Hafiz.
Allah
Allah
Hafiz, sir.
Hafiz.